GMO seeds are just one of the many ways Monsanto is helping farmers sustainably grow enough for a growing world. But they're also, without a doubt, the one we hear the most about. What are they? Why do some farmers choose to grow them? Are they really that scary? Give it a minute. GMOs are genetically modified organisms. When it comes to plants, there are 8 GMO crops. GMOs are adapted with beneficial traits that help them thrive in their environment. Think drought-tolerant corn or pest-resistant soybeans that need less bug spraying. That helps farmers, and better harvests benefit everyone, impacting what's available at the store and what we can put on our plates. Here's how it works. Plants get instructions for growth and development from their DNA, which contains thousands of genes. Researchers zero in on the gene containing specific instructions for a desirable trait. A copy of that gene goes into the DNA of host plant cells, which are grown into mature plants. Only after years of rigorous testing are the seeds from those plants made available to farmers. No syringes, no frankenfood. And much faster than traditional plant breeding methods alone. And with food demand expected to grow significantly by 2050, GMO seeds can help farmers sustainably grow enough.
Genetically engineered foods have deeply infiltrated the American food supply. Almost 90% of crops like corn, soybeans, canola, and sugar beets grown in the United States are now genetically modified. Genetic engineering promises increased crop yields, lower costs for farmers, and reduced use of herbicides. But are these goals really being achieved? Are you benefiting from genetically engineered crops or paying a dear price for you and your children's future? It's time for an awakening. Learn to separate the truths from the myths on genetic engineering. Genetic engineering is totally different from natural breeding methods. Its promoters claim that genetic engineering is a safe and beneficial process, even going as far as saying that it's an extension of natural plant propagation. The truth: this is a laboratory-based technique where a foreign gene is inserted into the DNA of the plant. This is an uncontrolled process because the site of insertion is random and may potentially damage the plant's genetic makeup. The mutations that occurred during the genetic engineering process can lead to many unexpected changes in the resulting crop, such as poor crop performance, alterations in the food's nutritional content, toxic and allergenic effects, and unforeseen harm to the environment. Genetic engineering does not reduce pesticide use. The proliferation of genetically engineered Roundup-ready crops has led to an increase in the amount of pesticides and herbicides used. The allowed residue limit of glyphosate, the world's top weed killer, has also been increased. Monsanto promotes Roundup, its glyphosate-based pesticide, as safe and having low toxicity, but these claims are based on outdated and questionable studies. Monsanto Agriculture France was even charged with false advertising after claiming that Roundup is biodegradable and leaves the soil clean after use. Roundup is not biodegradable. In fact, Roundup's glyphosate is classified by the European Union to be dangerous for the environment. Nature always adapts, paving the way for glyphosate-resistant superweeds. This requires the increased use of stronger pesticides. Producers of the genetically engineered seeds benefit from the massive failure because of higher farmer dependence on their toxic chemicals. Genetic engineering does not increase crop yield potential. Genetically engineered crops do not increase intrinsic yield and actually have the opposite effect. Glyphosate depletes soil quality by killing the natural nutrients and organisms that are necessary for the plant's development, leading to plant diseases. Glyphosate is highly invasive and can mix with rain, air, water, soil, and groundwater. Genetic engineering creates serious environmental problems. Increased pesticide and herbicide use affects wildlife and the non-pest insect population. The increasing propagation of Roundup-ready corn and soybeans heavily contributed to the fall in monarch butterfly populations in North America. Pesticides affect the health of both GMO and non-GMO plants and can potentially kill them. Studies reveal that glyphosate leads to increased rates of sudden death syndrome, SDS, a plant disease that causes plants to turn yellow and die. Genetic engineering does not help solve climate change. Genetic engineering is justified as a climate change solution, when in reality it does nothing to solve the growing global problem. Tolerance to extreme weather conditions is too complicated to be inserted into plants through genetic engineering. Genetically engineered crops are as energy hungry as any other chemically farmed crops. GM crops consume massive amounts of energy because they are largely dependent on herbicides, which use fossil fuels during manufacture. GM crops are also dependent on nitrogen fertilizer, which emits greenhouse gases. GM proponents claim that GMOs are energy-friendly because of this no-till method, which implants herbicides in the plant's genetic structure instead of plowing to control weeds, therefore reducing the number of tractor passes that farmers have to make across their fields. However, research revealed that even though the no-till method did reduce farm operations, large amounts of energy are still consumed due to the production of herbicides, mostly Roundup, used on GM crops. Genetic engineering will not help eliminate world hunger. Genetic engineering does not protect the security of our food supply and solve the problem of world hunger. For the record, there are no genetically engineered crops available that increase intrinsic yield. World hunger is actually an issue of allocation of resources. Food security can be addressed by natural breeding methods, which give birth to efficient supercrops like flood-tolerant rice, drought-tolerant maize, and pest-resistant chickpeas. There are no conclusive safety studies on GMOs. Most regulatory assessments on GMOs are only based on the data provided by biotech companies applying to commercialize GM crops, the same companies that profit from the positive assessment. The US FDA does not have a mandatory safety assessment process for GMOs. Independent researchers are also prohibited from using genetically engineered crops for their studies. As soon as they find problems with GM crops and foods, they are immediately criticized, their work called flawed and insubstantial. Claims of GMO safety and efficiency have been refuted by many independent studies, and yet these organisms continue to lurk and proliferate in our food supply. Over 50 countries all over the world have now passed GMO labeling laws and GMO crop restrictions in order to ensure people's health.
Well, in order to reach a conclusion about this ethical dilemma, we must first begin by examining the pros and cons behind this feat of genetic engineering. Increase in agricultural productivity. In the case of genetically modified foods, there are potential benefits to agricultural productivity through the development of crops more resistant to pest, disease, and severe weather. Designing pest and disease-resistant crops also decreases human and environmental exposure to chemicals and toxins. Improved productivity could result in more food from less land. Enhancement of food products. Genetic engineering can be used to modify food products in several beneficial ways. For instance, it could result in the blockage of genes associated with allergies, such as the potentially fatal protein found in peanuts. GMOs can also take the form of healthier foods. This has been done with golden rice, which has elevated levels of vitamin A. Additionally, engineering has allowed for the longer shelf life of fruits and vegetables. Widespread vaccination. Genetic engineering can be used to develop pharmaceuticals and vaccines in plants, decreasing the risk of adverse reactions and enabling faster vaccination of large populations. For instance, by incorporating a human protein into bananas, potatoes, and other fruits, researchers have been able to successfully create edible vaccines for hepatitis B, cholera, and rotavirus. Alternative energy sources. Another recent transgenic endeavor, known as the Glowing Plant Project, incorporated a gene from a firefly into a houseplant, creating plants that display a soft illumination in the darkness. One of the proposed goals is to create trees that could illuminate streets and pathways, thereby saving energy and reducing our dependence upon limited energy resources. Industrial and medical applications. One innovation is BioSteel, a high-strength, resilient silk product created by inserting the genes of a silk-spinning spider into the genome of a ghost egg prior to fertilization. There also exists the process of xenotransplantation, which is the transplantation of living tissues or organs from one species to another. This is often seen as a potential way to alleviate the shortage of human hearts and kidneys. Elusive labeling breeds distrust. To date, the Federal Food and Drug Administration has not required labeling that indicates a product has been genetically altered. This means that GMOs have been on the market for almost a decade without US consumers being alerted to their presence. This secretiveness has made consumers skeptical of reassurances that genetic modifications are safe. Negative environmental impact. Since plants are not self-contained organisms, there's the danger that genes may escape and find their way into other species. This would cause much devastation if, for instance, herbicide-resistant genes found their way into weeds. Other negative environmental impacts are the risk to birds, insects, and other species that come into contact with genetically modified plants. Unintentional public harm. There is also the potential that allergy-producing genes will be inserted into unrelated foodstuffs. Since genetically modified foods are not labeled, a person could suffer a potentially fatal allergic reaction. Support of large corporations. Small-scale farmers have reason to fear the negative impacts of a market dominated by a few powerful seed companies, such as Monsanto. Some are concerned that big corporations may use biotechnology to push others out of the market. A final source of distress is the politics and economics of allowing companies to essentially own organisms and potentially have a stranglehold on our food production. Questionable health effects. Several other countries, such as Australia, Japan, and the European Union, there are significant restrictions or outright bans on the production of GMOs, because they are not considered proven safe. In the US, on the other hand, the FDA-approved commercial production of GMOs is based on studies conducted by the companies who created them and profit from their sale. I feel that GMOs should be incorporated into everyday life, but only in the context of a specifically controlled setting. There should be strict regulations as to where genetically modified crops cannot be grown. It is also extremely important for the US to label any products that contain GMOs. The public should be given the choice to avoid these products if desired. This also serves to place consumer needs over that of large companies.